Hello everybody, this is going to be a walkthrough of the Honors Physics Practice Worksheet 3C on adding arbitrary vectors. As number 1 was already discussed in class, I'm not going to cover that. And for number 2 here, it reads about the Lockheed Blackbird record speed for an airplane. None of that is really relevant information. All you need to know is its max speed, which is going to be this number here, 3.53 times 10 to the third, which is equivalent to 3,530. We're going to need this later. So we're going to start off here getting the first vector. As you observe the plane ascending at this speed, for 20 seconds it flies at 15 degrees above the horizontal. So we're going to start by drawing a triangle here representing our first vector, as 15 is the angle in question. For 20 seconds it's going to fly at this speed. A little trick here, instead of going through all the time to convert this to meters per second, convert the seconds into hours, as this is declared as kilometers an hour. So little trick here, for 20 seconds, it's 1/3 of a minute, as 20 divided by 60 is 1/3. And now you have to divide this by 60 minutes in an hour. So you're going to take your 1/3 to divide by a fraction. You'd multiply by the reciprocal, and you're going to end up getting 1 over 180. This number is going to be very important. So after all that work, we now have our first time frame, and all we do is multiply this and then our time seconds here to get the magnitude of the hypotenuse, which is going to end up being 19.61. Just around, you just punch that in your calculator, somewhere around there. And now we're just going to do trigonometry to determine these two sides. So we're going to do the sine first. I don't know, I like to do the sine as its opposite over hypotenuse. So this is going to work out to being the sine of 15 times 19.61 is going to equal this side here. I declare everything as x because it's not really going to matter. So after you punch this in your calculator, make sure you are in degrees, not radians. You're going to end up getting a 5.08, and you're going to do the exact same work here, but just for cosine, as that will give you the other side, as you need to find this side. So you end up doing this in your calculator, and you're going to end up getting 18.94. You have your first vector done now. Yay. So this number we don't need anymore. We're still going to need its speed though, as we need to find our second vector. For 10 seconds, the angle is increased to 35. Again, we're going to draw ourselves another triangle here. 35 degrees. Now for 10 seconds, it's the same exact theory as the 20-second one, but it's just divided by 2, as 20 over 10 is just 2. So, because we all know it's half, so technically the math would be 1 over 180, and multiply that by half, and you're going to end up getting 1 over 360. Multiply these two together in your calculator, and you're going to end up getting 9.81, which is very logical, as this number is just about half of this number. And you're going to do the exact same thing here to find these two sides. You're going to take your sine, this time the angle is 35, and then you're going to end up multiplying it by the hypotenuse, and that's going to give you x, as x is this side. So after we go through that, you're going to end up getting 5.63, and as you do the same with cosine to find this side, you're going to get 8.04. Now that's all well and dandy, but how are we going to combine these into one vector? Well, you just add these two, add the bottom parts. You're going to create a final triangle here. This is theta, and you need to know this side. But the other two sides we already have figured out. We've already calculated these two sides. As to find these two sides, they're the sum of all of your vectors on the corresponding sides. As as this would work for as many infinite vectors, honestly, and as many vectors as we would have in the problem. So after you do the addition, you're going to end up over here, 10.71, and over on the bottom, 26.98. And now we would do the classic Pythagorean theorem to figure out what this side would be. And after you end up doing the Pythagorean theorem, I don't have the exact numbers. You just put them in your calculator. This side is going to end up being 29.03. Now we need to find theta, as theta is the angle. I like to use the inverse tangent, as it's very reliable, because if we mess up here, we still have reliable information for the others. As tangent is opposite over adjacent. We would plug this into our calculator to get theta. And theta, after you plug this in, would be 21.65 degrees. Now all that's left is to write a statement to tell what we've just found. So we have our magnitude first. Don't forget a unit. Excuse the at symbol. I'm trying to draw this on a mouse. At 21.65 degrees. Now, which way is this going? It's clearly going northeast. As if we drew the original, it would look something like this. Ish. And that's going northeast. As there are no negatives at all, so we can all assume that this is in the positive quadrant. So, 29.03 kilometers at 21.65 degrees north of east.